Okay. So we're going to discuss the graphing and slope practice. Then we're going to go over some notes for volume, mass, and density. And then we're going to, you're going to have some time to work on the practice for volume, mass, and density. Okay, so let's start with discussing the graph and slope practice. That was your assignment for yesterday, or yeah, the assignment that I gave you yesterday. So what you should do is open your graphing and slope practice in Notability. So do the split screen. So your WebEx on one half and your graphing and slope practice on the other. And then what we're going to do is we're going to take a look at some student examples. In the chat, what I want you to do is list the things that the student did right. So we'll start off with that, and I'll kind of give you some instruction on what we should be commentating on. And then what we're going to do is take a look at the student's work, and then we're going to talk about what they can improve, right? What did they do wrong? What can they do better? And then hopefully while we're doing all this, you can be making corrections to your practice so that when I grade those tonight, you'll be able to, you'll have a better score. Okay, so let's take a look. I'm going to go over to honors, and we're going to take a look at a couple submissions from, actually, before we do that, just real quick. So the first thing we're going to take a look at is the graph for this student's work. So what kinds of things should you be talking about? And remember, you start off with what they did right. So did they have a graph title? Did they have an X and Y axis title? Did those titles have units? Did they do their X-axis and their Y-axis scale right? Did they use the whole graph when they plotted? Are the data points plotted correctly? And does that best fit line go right through the middle of the data? So these are all things that you should think about as we're taking a look at this student's work, and we're talking about what they did right and what they can improve upon, what they can do better. So let's take a look. I'm just gonna, like I said, I'm just gonna kind of pick someone at random. Just kind of go right in the middle. I'm gonna go with you, Zoe. Hopefully that's okay. Okay. Zoom out a little bit. Well, that's the wrong thing. I want this. Okay. So let's start in the chat. What's one thing that the student did right? What's one thing that looks good on this graph? And so remember the sorts of things that we're talking about here. Graph title, axes titles, scale. Oh, good. We got some people commenting. All right. So Dylan said, whoa, they're coming in fast. Okay. So best fit line, X and Y axis are labeled with units. Yep. See that? Good best fit line. Good. Okay. So the best fit line's good. The units on the XY axis are good. How about the scale? Is the scale right? What do we think? Yeah, Dylan says the scale looks right. I agree. I think that scale looks great. They didn't put down every single number, but you don't have to. If you want to go 0, 5, and then, just have me know that that's 1, 2, 3, and 4, that's fine. Same thing coming up here. This is 5, 10, 15, 20. They just marked the 25. And that's absolutely fine if you want to do your scale like that. What's important about the scale is that you are getting is that you are making it so that you're using the whole graph. And this student did that very well. You can see that they pretty much used the entire graph to plot it. So that looks good. Okay, so we've kind of talked about what they did well, and the data points look like they're plotted correctly too, so that's good. What about what could they improve upon? What did they miss? Yeah, Sam says the title. There's no graph title on here, so what would be a good title for this graph? Someone else type that in the chat. Yeah, Eli, you agreed. No title. Good. What would be a good title for this graph? So, Mumtaz, you said volume versus mass. I'm glad that you said that. That's not right, but when remember we always go y, so this is our y-axis versus x. So you said volume versus mass, but really it should be mass versus volume. And it's okay if you forgot a title. You can go back and fix that, or if you didn't do your scale right, or your your best fit line, anything. The whole point of this is so that you guys can make corrections. Good. And so some of you are including units with your graph title. You can do that. You don't have to. The most important place to include the units is in the axes titles. Okay, good. So now let's take a minute and go back to the presentation. Okay. So I had you make a graph on this. I also had you answer some questions, right? And so what do good answers in science have? Well, they should have the correct number or value. Most of you did that correctly. Some of you need to make some corrections to your number or value. That's no big deal. Units, you should always include units with your answer in science. And I'm going to be nitpicky about that all year long. So if you're not including units, I'm going to be marking you down for that. And I'm going to be asking you to correct that to put units on there. Okay. So that can make corrections. And by the way, if you guys haven't figured it out, I'm pretty much fine with you making as many corrections as you want to these formative assignments. It's not like you do it once and then you're done. The whole point of formative work is for you to learn how to do it correctly. And so that might take some time sometimes. And so you just want to make sure that you're making those corrections. Show work, that's super important. So let's go back to this example. How would you go about showing work for these questions? What would the volume of a box be that had a mass of 75 grams? Zoe said 14 centimeters cubed, which I think is a good estimate. Let's take a look here. 75, she circled right here. That's good. And then down to 14. Well, Zoe actually did exactly what you should do to show work. You want to circle where on the graph. You could also remember in the lesson from Tuesday, I showed you that you can draw a line. You could do that too. You could draw a line from 75 to right here and then draw a line down here. That'd be a great way to show your work. Another great way to show your work is if you found the equation of the line, show how you could use the equation to answer this question, right? That's another great way to show work. So always make sure that you're showing work. There's very few situations where you shouldn't be. Okay, what would the mass of the box be that had a volume of 5 centimeters cubed? So it looks like you did the same thing, Zoe. You circled where on the graph you got that answer from, which I like. So you went from 5, because it was a volume of 5, up to here. And then you followed it over here, and it looks like it's a little bit bigger than 25, so you guessed 25 or 27.15, and so that's a great answer. Keep in mind, if you were close to one of these, that's still fine. It's tough to tell what the answer is exactly on this graph, and that's sort of why we like to use the equation, is that it will help us get exact answers. So other things that Zoe did well, used units on your answers. I love that. And then there's not really room to write it as a sentence here, but when I sort of give you a blank spot to answer a question, great answers are written as a sentence. And the reason why is because that's going to help you when it comes to writing your conclusions and your discussion questions when we get to those. And in fact, we're going to discuss that density lab tomorrow after you take some notes on mass and volume. And so you'll want to definitely, during that discussion, make sure that you're writing your answers as a complete sentence. Not a big deal on here because it's just that one little blank spot, so you didn't really have enough room to write your answer as a full sentence, so don't worry about that. Let's see here, find the slope. So for this one, number one, make sure that you're reading the instructions. No, never mind. You're fine. I'm thinking of a different problem. Yep, so this is good, 5.83. You would probably want to show how you calculated that. Zoe, do you want to give us some insight? How did you find that number, 5.83? I'm putting you on the spot.
Hey, can you hear me through my mask?
Yep, I can hear you.
Okay, so I noticed that there were 2 points that went directly through the best fit line. So I used those 2 points to do the y2 minus y1 divided by x2 minus x1 equation, and 5.38 was how I got that answer.
Excellent. So did you use this point and this point right here?
It's the point more at the very top.
Oh, at the very top. Oh, good. I see it. Okay. So basically you use the very first point and the very last point, right?
Mm-hmm.
Okay, good. Again, what we want to do is make sure that we're showing work. So what I'm going to do is open up a Google Doc and just kind of show what that calculation should look like. The very first point was 18 and 3.3. Okay, what's going on here? 18 minus blank over 0.3 minus blank. Okay, and then the very last point was 124 and 23. Whoa, 124 and 23. And 23. Okay, so then when we subtract those,
I did both the equations the other way around.
read the subtraction the other way around?
Mm-hmm.
Yep, and that's fine. So when Zoe set up her subtraction better because she's getting positive numbers, not negative numbers, I did y1 minus y2 instead of y2 minus y1. It'll still work this way though, but that's a good point, Zoe. And then 19.7. Okay, now my one criticism of your answer here, Zoe, because you ended up with 5.38, and that's fine. My one criticism of your answer though is there's no units. So let's talk about how we can do units on here. So when we're doing the subtraction of our x values, look, our x values are in grams. So we're just going to add that unit to the outside here. I'm going to say grams and grams and grams. Well, what were the units for our y? Our y was in centimeters cubed. So let's add that. Centimeters cubed. Oh, I'm sorry. X was centimeters cubed. Thank you. So X was in grams, Y was in, Y was in grams, X was in centimeters cubed. Thanks for pointing that out, Sam. Text, superscript. Okay.
The shortcut works on docs, but in Word you can do the caret, the little upward arrow, and it does the superscript automatically.
Really?
I don't know if the shortcut works here, but
let's give it a try.
No, okay.
All right, that's good to know though, if I'm ever in Word. Okay, so then this is what your answer should look like, 5.38 grams per centimeter cubed. If you're writing it as a sentence, you might say something like, the slope of this graph is 5.38 grams per centimeter cubed, or the rate of change is 5.38 grams per centimeter cubed. That's kind of what we're looking for here. Okay, this has taken a little bit more time than I thought. So let's keep her moving. This next question. Okay, so you wrote out the equation. That's good. You want to include units with your density. So this 5.38 should be, yeah, and if you got 5.25, Eli, that's fine too. It really depends upon which 2 points you use. Or maybe you didn't even use points from the table. Maybe you use points from the line. All of that will affect your answers. So it's not a big deal if you're not getting exactly 5.38. That's all going to depend upon which points you use.
Yeah.
So that's a good point.
I used these two areas on the graph where it intersected one of the bold lines almost exactly halfway through.
And that's perfectly fine if that worked for you for calculating it. Let's see here. Mumtaz asks, do I write the slope as a decimal or do I keep it as a fraction? We really write our slopes as decimals in science. And I've noticed that a lot of you have been writing your slopes as fractions. I'm assuming that's how they teach it in math, is to write it as a fraction. Is that correct? Is that how you learned it in your math class? Yeah, okay. Other people are saying yes. So yeah, they probably taught you in math class to write it as a fraction, and that's not wrong, right? Fractions are correct too. Fractions are really good for math because they'll give you exact answers. Decimals are really good for science because whenever we measure things, we never measure them as fractions. We always measure them as decimals. So like, for example, when you look at a scale in a science class, it won't say 5 3/8, right? It'll say 5.375. And so for that reason, we're going to be using decimals in science. Now, okay, so back to the equation. I'm not going to go over how you found the y-intercept, although I assume that it's correct. Basically, you're going to plug into y equals mx plus b to do that. What I am going to say, though, is this equation looks good. This is a good math equation. What can you improve upon? Well, you should really put in the variables for y and x. I know I wrote the language here poorly. It says you may write out the volume. It should say you should write out the volume and mass and use v for volume and m for mass. So what was our y variable? Well, that was mass. So what this really should be is m equals 5.38 times v plus 0.25. And I'm assuming that 0.25 is correct. I haven't actually checked that. That being said, you should also have units in here. So 5.38, that's your slope. Remember, our units for that is grams per centimeter cubed, right? Just like we did on the Google Doc here. 5.38 grams per centimeters cubed. That's how you should write the slope in there. And then for the y-intercept, that should always have the same units as y. So y was mass. Mass is in grams. So really, this should be 0.25 grams. And keep in mind that I haven't actually checked this, the number, so it might be different than 0.25, but the way you figure it out is you take one of your points, let's say 124 and 23, you plug in 124 for y, you plug in 23 for x, and then you solve for b. So you would write b in as a variable and solve for it. Let me ask you this, other people, did you get around 0.25 when you solved it? And it's okay if you didn't, but go ahead and comment. Or let me put it this way. Why don't people comment? What did you get for the y-intercept? What did you get for b? Sam says he got around 0. Nicholas says he got 5. Sam says he got negative 0.65. 0. Okay, we're getting kind of a variety of answers here. So let's just kind of show how to solve this real quick. So m equals 5.38 copy grams per centimeter cubed times V plus B. Now, the reason why you write it out with M and V is now it's going to be really easy to plug in when we take a look at our table. We just have to look at what M and V are for 1 point. I'm going to use, actually, before I said I was going to use these two, I'm actually going to use these two because the smaller numbers seem easier to me. So 18 and 3.3. We're going to put in 18 for the mass. Copy. We're going to put in 3.3 for V. And we're going to solve for B. But keep in mind that the mass is in grams, the 3.3 is in centimeters cubed. Okay. All right, so then we're just multiplying here. So we're going to end up with 18 grams equals, and then I need a fresh tab here real quick so that I can calculate that. 5.38 times 3.3. 17.8. So I'm thinking you're going to be pretty close, Zoe. 17.8 grams per centimeter. Grams per centimeter cubed. No, just 17.8 grams. Sorry, my bad. And then plus B. So if you're wondering where I got that unit 17 grams for, the centimeters cubed here, because that's on bottom of the fraction, is going to cancel out with this centimeters cubed here. And we're just going to be left with grams. So 18 grams equals 17.8 grams plus B. And then our last step is going to be subtract 17.8 minus 17.8. And then what we should get is 0.2. So Zoe, you got 0.25. That's pretty close. 0.2 grams equals B. Now, this will change depending upon which 2 points you use. So it's going to be different if you use 2 different points or if you're using the line, your best fit line from the graph to estimate. The answer should be about 0. So if you're getting an answer close to 0, you're on the right track. Again, though, because we're estimating the best fit line, if you're using points that are on the best fit line, that will change what your answer is. So don't worry if you didn't get 0.2 exactly. You're only going to get 0.2 if you pick the exact same points that I did. If you pick different points, that's okay. What's important is that you're writing out your formula in the correct form. So your formula, and that's what I really want you to do correctly. If you know, and I want you to find the right B value. But at the end of the day, if it's not exact, I'm not gonna worry about that as much. What I really want you to learn is how to write this formula. So M, that's our Y variable, equals 5.38 grams per centimeter cubed. That's our slope. And keep in mind the units for the slope, that's the Y units over the X units. Then it's our X variable, volume, and then plus 0.2 grams. That's what I calculated the y-intercept. You write what you calculated. If it's not 0.2, that's fine. But just make sure that you're including the y units. The units for mass is grams. Does anybody have any questions on that?
What was her favorite music?
Did I ask that one on this question?
The answer to question 10. Yeah, I think it was this one.
All right, let's see what your favorite music is, Zoe. We're going to skip going over the slope ones because I think people get how to do that. Oh, she doesn't listen to music. It is what it is. All right, so good. So go ahead and make corrections to this, and resubmit if you feel like you need to make corrections to it. I'm not actually, just so you were in full disclosure here, I'm not actually going to grade and leave feedback on this. I'm just going to check to see if you did it. So this whole bit, the making corrections, that's for you because you're going to need to know how to do this on your summatives, right? But if you make corrections on your formative, that will help you do better on your summative. So that's the whole purpose of this. Okay, we should move on though and take notes. Let me go full screen. Try to get some of this WebEx stuff out of the way so that I can see what I'm doing here. All right, so, whoops. Okay, so what should you be doing right now? Well, we're going to be taking notes. So you should get your notebook out so that you can take notes. And if you have questions, type them in the chat and I'll try to answer them as we go. Okay? All right, so table of contents. This is mass, volume, and density. You should probably date your notes for today, 9/17. I didn't update the first thing, but that we took our first notes on Monday, whatever that was, the 14th, I think. Okay, so our essential question for today's lesson is, why is it important to know how to accurately measure mass and volume? Well, this isn't a great answer, but one of the reasons why it's important to know this is because you're going to need to know that for our discussion tomorrow on the density lab that you did at the start of this week. But also, this whole unit is about graphing and measurement, and so you're going to need to know how to measure a lot of things, but specifically mass, volume, and length. And then you're also going to learn how to calculate density. You can't actually measure that directly. Okay, so measuring volume. And I kind of talked about this in the density lab, but when using a graduated cylinder, you always measure the volume at the meniscus. So when you look at water inside a graduated cylinder, it kind of makes this sort of like curved little bubble shape. And you always measure from the bottom of that little bubble. And so that's how you do your measurements. And so that'll be important when you do the practice for today. All right, so how do you find volume? Well, there's two methods that we're going to talk about. The first method only works if you have a rectangular prism, or maybe more simply a box. And this method's pretty simple. You just multiply the dimensions of the box together. So you multiply the length, so that would be 10, times the width, which I would say is 2, right? That would be this distance right here, times the height, which is 5 centimeters. You multiply them together, so 10 times 5 times 2, that's 100. And then you multiply the units together as well. So centimeters times centimeters times centimeters, That's centimeters cubed because we've multiplied 1, 2, 3 centimeters together. Oh, sorry. Mara had a question. Do we need units for questions 6 through 9? Let's just take a quick look at that, and then we'll come back to the notes, folks. So questions 6 through 9. Please find the slope. No, you do not need units because there's no units on those axes. So that's a great question, Mara. This is just supposed to be some quick practice on slope. No, you do not need units for those. You can just write the number down. Good question. Oh, that was, sorry, not, oh yeah, Mara asked that one. Okay, good. Okay, so let's keep going here. So for volume, 100 centimeters cubed. So units for volume should be centimeters cubed. Method 2, water displacement, used for weird or irregular objects. This was developed by the Greek philosopher Archimedes. Now, I'm going to tell you a story here. I don't actually know if it's true or not, but the story goes that Archimedes, the Greek philosopher, was taking a bath. And he was trying to come up with an answer to this problem, which is, how do I find the volume of an object when I can't, just simply calculate it with math? And so the story goes that he sat down in the tub and he saw that the water level rise. And at that point, he had an epiphany and started running naked through the streets, screaming, "Eureka, Eureka, I found it." Because he discovered that you could determine the volume of an object by how much the water level rises. So how does this method work? Well, you fill a graduated cylinder with some water and you record the volume at the start. Then you carefully place an object in the cylinder and then you record the new volume. And then the change in the volume of water is the volume of your object. So basically you subtract the old volume from the new volume. Why does this work? Well, two objects can't occupy the same space, so when you drop something in the water level rises. So let's take a look at how that works in practice. So here we've got a graduated cylinder, and if you measure from the bottom of the meniscus, apparently this is 75 milliliters. And then if you drop, so this is like a rock, if you drop the rock in there, the water level rises to 98 milliliters. 98 minus 75 is 23. So then that means that the rock has a volume of 23 milliliters. So the units for volume in this case are milliliters. Well, wait a second. Earlier I told you that the volume was centimeters cubed. A centimeter cubed is a milliliter. The way that we came up with this volume is someone just decided, well, the way that we came up with a liter is someone decided to take a decimeter, which is 1/10 of a meter, and make a box out of it. So it was 1 decimeter tall, 1 decimeter wide, 1 decimeter long. And then they decided that that volume was going to be a liter. And so then if you divide each of those dimensions by 10, you're dividing a liter by 1,000. And that will get you to a milliliter. A milliliter is 1/1000th of a liter.
The
You don't
metric
need to know
system makes
all that.
so much more sense.
Okay, good. So you don't need to know all of that yet. We'll go more over the metric system in the coming lessons. But what you do need to know is that the units for volume are either going to be milliliter or centimeter cubed, and you can use them interchangeably because it's the same amount. So volumes practice. What are these volumes? So go ahead and type in the chat for the box right now. Try to calculate what that volume is. And remember to use units. All right, looks like you smarty pantses all got it. It is 40 centimeters cubed, or 40 milliliters, right? Those are both correct. So 4 times 5 times 2 Well, 5 times 4 is 20, times 2 gets you to 40. Centimeters, centimeters, and centimeters gets us to centimeters cubed. Okay, how about go ahead and do, go ahead, I see Hunter already did it. Go ahead and do the graduated cylinder next. Tell me what the volume of that graduated cylinder is. Yeah, a lot of people are saying 38. Hunter said 38.5. That's a good guess too. Now remember, we're measuring from the bottom of the meniscus, so that kind of goes through this line right here. Each line, since there's 4 lines in between, so well, really 5 if you count from 30 to 40, right? 1, 2, 3, 4, 5. That means each line must represent 2 milliliters. So this is 30, 32, 34, 36, 38 milliliters. Okay, good. Seems like most of you got that, so that's good. If you have questions, go ahead and type them in the chat. But we're going to go ahead and move on. And so, yes, those were the answers, 40 centimeters cubed and 38 milliliters. Okay, so mass, how much matter or stuff an object has. So mass just tells you how much stuff is there. We always measure mass in grams, and we use a balance or a scale to measure mass. So you guys kind of saw me on Monday with the density lab measuring it with the measuring the graduated cylinder on top of the scale. Okay, quick fact about water. For water, 1 gram equals 1 milliliter equals 1 centimeter cubed. That is not an accident. When they developed the metric system, and when they decided what they wanted their unit for mass to be, someone took 1 centimeter cubed of water, or 1 milliliter of water, and massed it, and that became the unit for a gram. Is they said, oh, here, I've got 1 milliliter of water here. This is going to be our basis for mass. Hunter, I see you have kilograms. That's good. That is the Institute of Science base unit for mass. A kilogram is just 1,000 grams. And we'll talk more about kind of how you go from like a meter to a centimeter, or a milliliter to a liter, or a gram to a kilogram in a little bit here. Some of you might already know that. But we're going to get into that in a few lessons here. Okay, so then density. Density is just mass divided by volume. Units for density are always going to be grams per milliliter or grams per centimeter cubed. That's not actually true. I've also seen it written as like kilograms per meter cubed. But for our class, we're going to write our density as grams per milliliter or grams per centimeter cubed. This is a density triangle, and this will help you figure out the relationship. So the way that I think about this is if I ever want to figure one of these out, I just cover them up. So if I cover up D, what's left is M and V, and what's in between M and V is the division symbol. So that means that density equals mass divided by volume. Similarly, if I want to find mass, I cover up mass, look what's left, D and V, and there's a time symbol in between. So the equation to find mass is just density times volume. If you know how to use algebra to rearrange this equation, you can end up with 3 different equations. And the third equation, if I cover up volume, is just mass divided by density. Does anybody have any questions about that? So let's talk about how we use that. I think there's an example in here. Yeah. Okay, let's go on to this one. So how can we use that density triangle to solve this? It says, what is the density of the rectangle if the mass is 500? So this is a 2-step problem because I gave you the mass. So let's go back here. I gave you the mass. I'm asking you to find the density Well, you're going to need the volume to be able to do that. So the first thing that you need to do, the first thing that you need to do to solve this problem is you need to find the volume of this rectangle. So go ahead and do that. Find the volume of the rectangle, and then see if you can use the mass and the volume to figure out the density. Correct, Hunter. That is a prism. That is a rectangular prism. I called it a rectangle. It's really, if you wanted like a more layman's term for it, it's a box. But the technical math term is rectangular prism. Okay, so go ahead and calculate the volume of that box or rectangular prism. And then afterwards, try to use the mass and the volume to find the density. And then when you think you have an answer, go ahead and write it in the chat. Okay, people keep getting 5.5 repeating. Okay, so the mass is 500. The volume, if I take 3 times 15 times 2, well, 3 times 15 is 45. 45 times 2 is 90. So to solve this one, I'm just going to go back to my scratch here. My density is going to equal 500 grams divided by 90 milliliters or centimeters cubed. I'm just going to use milliliters because it's easier to type out on a computer. And then 500 divided by 90 equals 5.5 repeating, you smarty pantses. All right. So then how do we round it? Well, there's actually like a whole lesson that I could teach on how you actually round things in science. I'm just going to go 2 places after the decimal. Although technically this one should only be 1 place after the decimal, and this would actually round up to a 6. So 5.56 grams per milliliter would be our density for that first one. Okay, let's go back here. All right, so then go ahead and try the second one. Find the mass of an object whose volume is 12 centimeters cubed and the density is 3 grams per centimeter cubed. So this one is a little bit easier because it's only a 1-step problem. Just use this triangle to try to solve for it. And we're finding the mass. So you'll cover up mass, and that will tell you what to do with the other answers. Okay, let's go back in the chat. Hunter says he got 36 grams. So did Dylan. So did Benjamin. Eli, Isaac. Good. Yep. So when we cover up mass, look, it's density times volume. So we're going to take our density, which is 3 grams per centimeter cubed, and we're going to multiply times our volume, which is 12 centimeters cubed. Okay, so then if we write that out, mass equals density times volume. Mass equals 3 grams per, and again, I'm going to write milliliter instead of, well, I'll write centimeters cubed just because that's what the problem said. Format text, superscript. So 3 centimeters cubed. Format text. Times 12. Times 12 centimeters cubed. And when you do that, the centimeters cubed will cancel out, and your mass, which should always be measured in grams, comes out to be 36 grams. Okay, excellent. That's all I have for you today. There's about 5 minutes left in class if you want to get started on the practice. It's just doing more of this type stuff, finding the volume and the mass and the density of stuff. If you have questions, there's 5 minutes left in class. Now would be a great time to ask them. I can answer them. Otherwise, that's all I got for you today. Excellent. Thank you, Leslie. Have a good day, too.